Alright, so now we're here at the trash again. And the trash is known as a Coxi bar. But actually, I wish I could meet also other students.
Yeah, that would be pretty interesting to calculate how probable it is to meet other people here. Maybe Lisa knows how to calculate those probabilities.
Well, let's see. First, our given points. These are that there are 13,000 students at the University of Osnabrück, of which around 6% frequent the bar. And of those students, 650 study Coxi. And of those then, around 70% frequent the bar. Our chosen denotation for the entire exercise looks like this. If we then transform our given points, it comes to p of bar is 0.06 and p of bar, given that they're Coxi, is 0.7. And now let's actually calculate the probability that a random student in this bar is a Coxi. We know that the probability that a student is a Coxi is 0.05 by dividing 650 by 13,000. We also know that the probability that a Coxi frequents the bar is 0.7. For this question of joint probability, we can use the product rule that we know from the lecture. And inserted with our variables, it would look something like this. So let's now insert our given values and multiply them. And this multiplied equals to 0.035, which in conclusion means that the probability that a random person in this bar is a Coxi is 3.5%.
Alright, and what is about the people at the bar who do not study Coxi?
For this question, we use the sum rule, which we have also already seen in the lecture. This inserted with our variables would look something like this. So now we can transform the rule to calculate the probability that someone frequents the bar and is not a Coxi. Here you use the probability that someone frequents the bar, which is already given through the sum rule and is 0.06, and subtract that by the probability that someone frequents the bar and is a Coxi, which is our solution from part A. This equals to 0.025, which in conclusion means that the probability that someone frequents the bar and is not a Coxi is 2.5%. But can we also calculate the conditional probability that if they're not a Coxi and they frequent the trash with the sum rule?
Yeah, this we cannot calculate with the sum rule. In order to calculate the probability that they frequent the bar if they are not a Coxi, we have to use the product rule, which was introduced in the lecture. In our example, it looks like this. So the probability that you meet a student in the bar and that he is not a Coxi is the product of the conditional probability that someone frequents the bar if he is not a Coxi and the probability of not being a Coxi. We are searching for the conditional probability that a non-Coxi visits the bar, thus we need to transform the term. We divide the equation by p of not Coxi and swap the two terms, so we get the following equation. So we just need to calculate the fraction. The numerator was calculated in the last task, the probability of meeting a student in the bar and that he or she is not a Coxi is 2.5%. The denominator can be calculated by the data given in the instructions. To calculate the percentage of non-Coxis, we simply subtract 1 by the percentage of Coxis. So we have 1 minus 650 Coxis divided by 13,000 students, and the result is 95%. So at the end we just divide 2.5% by 95% and we get 1/38. So out of the students who do not study cognitive science, around 2.6% frequent the bar.
Cool, interesting.
True. But Sasha, do you have any idea of how likely it is that at least one of the first 10 people we see here at the bar is not a cognitive science student?
Okay, let's get this done. To make it more clearly, let's imagine you're going to the bar and you will meet 10 people. What is the probability to meet at least one person out of your Coxi bubble? So what information is given? We know that in total 780 students frequent the bar, where 455 are Coxis and 325 students study other subjects. Here we see a simulation of the possible cases. The beginning probability to get to know a non-Coxi is 325 divided by 780. On the other hand, the probability to meet a Coxi is 455 divided by 780. Regarding our initial question, it is easier to calculate the counter probability first, which is the probability of meeting 10 times in a row a Coxi. In order to do so, we need to multiply the probabilities along the counter cases. And then we need to subtract 1 to find out the actual probability. But now we need to pay attention. Obviously, we would not meet one person twice. The person we have met before must be considered in our calculation. Regarding the probability of not meeting a Coxi, it means we have to subtract 1 from the denominator. Regarding the probability of meeting again a Coxi, we must subtract 1 from the denominator and the numerator. Because the previous Coxi must be taken from the number of all students at the bar and the number of Coxis at the bar. So eventually, the formula to calculate our counter probability is the product of 455 minus I divided by 780 minus I, where I is the index and goes from 0 up to 9. But then in the second step, we will subtract the counter probability from 1 in order to find out the actual probability of meeting at least one non-Coxi out of the first 10 people we meet at the bar. Then the final result is above 99%.